We are going to start with an experiment for configuring the switches and the routers in a network. It is just an expansion of the experiment lab 1 that was for the configuring of switches and the devices. Just the difference is that there are more two equipments that such as routers connected into the network. The reason for connecting the router is that it provides the routing for multiple devices in two different networks. Okay, so over here the configuration is consisting of two routers, that is the router 2911 and a switch 2960. Now, while considering this network, when we need to connect two routers with each other, we cannot just directly connect it using a straight through cable, which is considered in the case of switch and the PC, in which the straight through cable is used for PC through to switch. But in the case of router to router, we can use either serial DC or serial DT. When using serial DT, it is the cable is used for accessing the data. While considering serial DC, we can it transmits in the form of clock pulses. Okay, so when the interface has been configured, now it's time to assign a serial port to assign no no sorry the to set up the interface, that is a serial DC. We need a serial port on the router to get attached to it. We cannot just directly connect to it as the router doesn't contain the serial port default. So to add that module, serial module, we just need to click on the router. Over here you just need to first initially close the switch, and you can just click this HWIC2T, that's the serial port module, and you need to drag and drop on the router panel. As soon as it is drag and drop, you need to switch on this switch, and yes, here the router gets configured. Similarly, you have to perform this module in the second router also. After that, you can just connect the serial DC cable for which in between the two routers. Now there are few commands which was similar to the lab experiment one. Those are for the switch you need to configure the host name and the other details for the telnet and SSH session, which already we had already performed in the lab 1 experiment using these commands. Just the difference over here is that we are using interface fast ethernet 2.0/2. That means over here, as you can see, that the fast ethernet 0/1/0/2 and 3 and 4 are up, as there are 4 devices connected to each in VLAN 1 itself. And similarly, you in the router you can see that the VLAN gigabyte ethernet 0/0, that is up, that is shown as 10.0.0.1. Over here you can see that's the IP address of the router, and the switch the IP address for the switch is 10.1.1.10, and its subnet mask is this in the interface VLAN 1. Now the command over here, no shutdown, means that we are just changing the state of the interface to up and not down. Exit, it will just come out of the configuration section. Now we are even assigning an IP address, that is a default IP address, in to directly know that the a system that the network is in the network has to go through this IP address itself, that is 10.1.1.1. The default IP is for router 1 is 10.0.0.1, and the default is 20.0.0.1 for another network. After this, while configuring the routers, you need to mention all these commands that is similar to the switch configuration. Just the difference over here is coming over here. Here interface gigabyte ethernet 0/1, which means over here, as I had shown you, uh, over here as you can see, the gigabyte ethernet 0/0 is up, that we have already configured the port, and we have assigned the IP address, that is 10.0.0.1, that is the IP address of the router, that is the default address for router, not the default gateway. It is a default address IP address of the router, and I have assigned the speed as 100 Mbps. It can be up to 1 Gbps. Even after that, I have also configured the interface 0/0 0/3/0. That's the interface for this between the routers and routers, and over here you can see that IP address 30.0.0.1 and its subnet. The meaning of this is that whenever a system from network 1 wants to communicate to network 2, it has to first communicate to the serial IP address of the sorry, over here it's 2. You need to just go in the whenever a system wants to communicate to direct to, it needs to first find the 30.0.0.2 IP address, and this is the entry point where the packet enters into the network. And you need to just no shutdown and click on the bandwidth. No shutdown is for the changing the state of the line up, and bandwidth is 128, and exit. Similarly, this has to be performed on the router right, but the changes is that for router right, it should be routing it whenever packet from this network wants to travel to this network, it has to go in the 10.0.0. network and its default IP, and from this IP address, that is the uh, endpoint, right side endpoint of the router, that is the 30.0.0.1, from this network to 10 network. Even here the default gateway is 10.0.0.1. Okay, now after configuration of the packets has been done, now it's time to show the simulation that a packet is being traveled from one network to another network. I will to for showing the simple PDU, you just need to click on the plus message button over here, add simple PDU packet data unit, and you need to click on a device over here, and this is the source, and where the packet you need to respond, you just need to click on these any system of the another network. Suppose I have done this for the PC3, I have already done so in the simulation. I'll just show you. You just need to reset. Now you can see that there is a mail protocol over here, and you just need to start. Over here you can see that the message is being sent from the PC1 to the switch. Now from the switch it will be transmitted to the router, and from the router it will be going to the router or 2 of the second network. From the second network it will be going in the switch of the second network, that is the second switch in the network, and from there it will be receiving to the packets over here in the PC5, as I had added a simple PDU for PC5. Now the packet has been sent, now it's time to response. So to check whether the inbound and outbound of the packet is proper or not. What is inbound? Inbound means that the packet was inside the network, and outbound means the packet is out from the outside of the network. So for that you can just check over here, over in this section you can check the inbound and outbound PDU. So from PC0 it was in the switch 0, so you just click on the switch 0 and you can get a PDU information, the inbound PDU. That here you can see that the source and the destination over here. Over here you can see that the source and the destination is from the network. The source is from the network 1, and the destination is at network 2. Similarly, from switch 0 to router 1, router 1 to switch 1. Okay, here router 1 to 10, router 10 to switch 1, and switch 1 to PC5. Now the packet has been sent to the PC5, that the ICMP packets has been sent. Now it's time to check whether the response is proper or not. For that you just need to click on the switch 1 from PC5 to switch 1. You can just mark the changes over here again, and here. So for that was in that case the source IP was 10.0.0.2, and the destination IP was 20.0.0.4. Now it has changed, that it has been that it is the response from the packet, a response of the packet from the another network to the previous network. And here you can get the outbound PDU also, as I mentioned, it is for the inside the network and for the outside of the network. So here we are just completing the simulation of the second experiment. Thank you.